Hello everyone, I'm Patricia Sewa and I'm here with my co-member Pamela Provençal. Okay, today we'll be presenting our project titled AI Telemedicine for Tuberculosis Detection. Basically, our project is about using artificial intelligence to detect TB early and to provide useful health information all from your phone or your computer. Okay, so think about this. Imagine being able to detect a serious disease like tuberculosis without stepping into a hospital. And in most parts of the world, people can't get tested quickly because hospitals are far away or the resources are limited. But what if AI could do that? That's exactly what we tried to do with this project. Our system has two main parts. And the first one is a deep learning model that looks at chest X-ray to help detect TB. And the second one is an intelligent chatbot that gives users information about TB, like their symptoms, how to prevent it, and the general health tips. So we built this using Python, TensorFlow, and Pikachu, which makes it easy for anyone to use. So in the first part of our code, we imported all the necessary libraries we will need. We imported TensorFlow and the TensorFlow and the Keras for building the deep learning model, then NumPy for numerical operations, Matplotlib for the visualization, the skitlearn for evaluation, and OS zip file and shuttle for handling the files. You didn't see us installing any of these because Colab already has it installed. It's a local library on Colab, so we didn't need to install it. All we needed was to import it. Then we also defined a configuration dictionary called the condiv, which stores important parameters like the image size, the batch size, learning rate, model path, and the seed. Then the next code checks the working directory and displays its content. Then since it runs in Colab, we upload the datasets manually using files.upload. This allows us to bring the TB X-ray datasets as zip file. Then we extracted the zip file containing the dataset. First, we check if the directory already um, already exists and delete it. Then we create a new directory. Finally, we create a new directory. Then finally, we extract the files, all the files we need for the training. Yeah, sorry. Then in our next step, we organize the data set into three main folders, which is the training, validation data, and test data. We also define the path of TB images and normal images. This structure is important because deep learning models require well organized datasets for proper training and evaluation. Then think yeah, so processing this place we are processing our images for the model using the image data generator. We rescale the pixels values to between 0 and 1. We apply data augmentations like the horizontal flipping for the training. Then we loaded the images into batches.
This helps improve their performance and prevents overfitting. So I think yeah, this one. So yeah, we pre-trained our model to remove the top, and we pre-trained our model called the efficient net BO, which is trained on ImageNet. We remove the top layers, freeze the base model to keep length features, add new layers like global average, pooling, and how do you say dense layer with REL. This allows our model to classify images as TB or normal. Then in our next step, we train the model using the training dataset. The early stopping happened. So after pre-training our model, we evaluate the model using the test dataset we had earlier. The model predicts results. We convert probability into class labels. Sorry. Then we use a classification report to measure the performance. This includes accuracy, precision, recall, and F1 score. Then our next code is we created a function called predict images. So we know this function, what it does is it loads an image, resizes and normalizes it, passes it through the model output, whether it's TB or normal, along with confidence. This makes the model usable in real world scenarios. Then our final um, code is the gradual interface. We built a user interface using the Gradle. We installed Gradle and GTTS for voice output and the how the app allows users to upload an X-ray image. The model predicts the results and optionally gives audio feedback. This makes the system interactive and user friendly. So this is our interface. So first, our interface is when you see our interface, you have to sign up first. I'm going to sign up with my yeah. So sorry for it. It has it says sign up successfully. So now we go to the diagnostic part. Enter our username, which is the upload my image, which is a TV image I got from the internet. So now our image is here and analyze it. So this is an AI report. Then prediction it says tuberculosis. Then probability of the tuberculosis is 0.82, which is high risk. Then it gives you a warning that it's an AI assisted only and not a medical um, diagnosis diagnosis. So which basically means like it should solely depend on the issue. Consult a professional medical doctor or professionals. Yeah. Then now let's try our chatbot. So Yeah, it says I'm your AI TB assistant. Ask you about symptoms, preventions, or describe your symptoms. So I'm going to ask it symptoms of tuberculosis. So as you can see, our answers are in. It says TB symptoms, persistent cough, coughing blood, chest pain, fever, night sweat, waist loss, then fatigue. And note, our chatbot doesn't hallucinate. It gives answers with the data it's being trained with. So it doesn't hallucinate. And also our chatbot has an audio output which helps users to listen to answers given by the chatbot. So let's This makes our system interactive and user friendly. Yes. So to sum everything up, this project uses deep learning to detect tuberculosis. It leverages the transfer of better accuracy and provides a simple interface for users. This can help improve early diagnosis and support healthcare systems. Our health is not just in the hospital, but it's in our hands. Thank you for your